Okay, in this video I'm going to discuss another option as a follow-up to significant factorial MANOVA results, and that is the use of step-down analysis. In my previous videos I discussed the use of univariate follow-up tests and including interpretation of Tukey's post-hoc tests and looking at simple effects tests and so forth. As a way of following up the MANOVA results. So in other words, we ran the MANOVA results and then followed those up with the univariate ANOVA results, which in turn were followed up by post hoc tests and simple effects tests. That's a common follow-up strategy, but the downside of this is that it sort of violates the reasoning behind performing the MANOVA in the first place, which is that the dependent variables are likely to be intercorrelated. So the MANOVA's the aim of it is to take into account the intercorrelations among the dependent variables and compare groups on the dependent variables simultaneously. The unfortunate thing in SPSS is that by default univariate test results are printed out following the MANOVA test results, and so I think a lot of times the univariate tests sort of become paired in people's minds with the multivariate tests. But these are two different sets of tests, and the idea behind the univariate ANOVA results and any kind of follow-ups like Tukey's or simple effects tests and so forth is to sort of unpack the univariate ANOVA results. But again, you're sort of running back into the problem that these are not really consistent with the aims of the MANOVA. So another option that is a little bit more consistent with the goals of the MANOVA is to run step-down analyses. And so to carry out step-down analyses, what you would do is essentially create a syntax file, and this is an example that's based on the data that's presented right here. So I have, in this case, I've got two independent variables that are categorical. I've got intervention and gender. So intervention has three groups: intervention A, B, and C, which are coded 1, 2, and 3. Gender has two levels of 1 for male, 2 for females. The remaining variables are my dependent variables, and they are treated as continuous. So in step-down analysis, when I ran the MANOVA, I basically had specified my intervention, gender as my fixed factors, and the remaining three variables as the dependent variables. In running the step-down analysis, what I do is I just basically am going to use the MANOVA command, but then indicate that I want the step-down analysis. So in this syntax right here, I've got a title line, and in the single quotes I've got the name of my analysis. So this can be anything. This is just the name that I gave this particular analysis. Follow the single quotes with a period though. And then I've got the MANOVA command, and then I've got my three dependent variables listed. So I've got self-efficacy, utility, and intrinsic motivation listed. And the thing about it is that this listing needs to have some kind of represent some type of prioritization of the dependent variables in terms of an order of importance. And the reason why is because the step-down analysis proceeds by starting off with basically a standard univariate ANOVA comparing groups on the first variable that's listed in this order. Then it will carry out a second univariate ANOVA, but in this case it's going to incorporate a covariate, and that covariate being the variable that's listed previous to that. So in effect it's going to be a univariate ANCOVA model that's tested. And then you have a subsequent ANCOVA where basically you would have self-efficacy and utility included as covariates, and you're comparing groups on when you're comparing groups on this last variable. So So there's a definite priority that you're assigning to these variables, and it doesn't matter which goes where, just that there generally needs to be some logical or theoretical reason for ordering the dependent variables in the way that you specify. So in this case, I'm giving top priority to self-efficacy, next priority to utility, and the lowest priority to intrinsic motivation. So these are the DVs, and you follow it up with a by command, or a by statement, by the name of the one of your independent variables. So my independent variable name was INTERV, capital I there is, and in the parenthesis I've got the values for the lowest value and the highest value for that variable, which are 1 and 3, which represents intervention A and intervention C respectively. So these are minimum and maximum values. Gender also has values of 1 and 2, which are minimum and maximum values representing males and females. In the line with the backslash and then print equals cell info, and in the parenthesis type means, then SIGNIF or signif, and then in the parenthesis include step down, and then backslash, and then period. So when I run the result, run the analysis, I highlight everything, click the green button, and so now I've got all my descriptive statistics, cell means, and so forth. And then you'll notice that in terms of the results, it's broken down. You've got the multivariate effects, univariate tests, as well as the step-down tests. So the first thing, kind of note that it's got the multivariate tests of significance. So right here we've got, this is the MANOVA result that was in the previous table for the interaction of intervention by gender. If we go down a little bit further, we have essentially the multivariate test results for gender. So these are the MANOVA results that appear in the earlier table that I showed you. And then, if you go down a little bit further, then we have the multivariate test results for intervention. So here's that test right here, the Wilks test for that. So in other words, basically those three tests are what appear in the earlier MANOVA summary table right here. So there's the effect of intervention, gender, and also the interaction. The next set of tests that you see printed out in the step-down results for each effect are the univariate ANOVA tests. So in other words, we in this case right here, we're looking at the effect of intervention by gender on self-efficacy, perceived utility, and intrinsic motivation. And so these results are also printed out with respect to the gender effects, which you can see down here, down below. You have the univariate F-test for gender, so this is self-efficacy, utility, and intrinsic motivation. And then down below that, you've got it for the intervention. So here are the univariate F-tests for intervention for these three variables. So these tests right here are basically what are printed out, going back up to our earlier results, in this table of tests of between subjects effects. So you've got, in this case, intervention effects on each of the DVs, gender effects on each of the DVs, and then the interaction effect on each of the DVs separately. So what is actually new in the step-down results is the actual step-down tests. So here they are, and so for and actually what I'll start off with, I'm going to actually start by going with the simpler ones, which we're going to just look at the step-down results first of intervention on each of the DVs. So the first test right here is you'll notice that it's looking at the effect of intervention on self-efficacy. And this result right here is going to mirror what you actually see in the test of univariate results. So you can see the F value is exactly the same. The second test is an ANCOVA, and essentially it's looking at the effect of intervention on perceived utility, controlling for self-efficacy. So you'll notice that the results that are printed in this line, some of the values are going to be different from what you see in this line, because this is basically reflecting a zero-order relationship between intervention and utility, whereas this one is reflecting the relationship while controlling for self-efficacy. Then you have intrinsic motivation, which is the variable we gave third priority to, and so you can see that in this case we're running an ANCOVA where we're looking at the effect of intervention on intrinsic motivation, covariating out or controlling for self-efficacy and utility. And again, these results, a number of values here are going to look different from the values that you see in this line. So basically it turned out that it didn't really matter how we well, it didn't really matter when we compare the univariate results versus the step-down results. There's not really much in the way of a difference in terms of the results that were exhibited between these two sets of tests. Okay, so let's go up and look at gender. So in this case, we've got our gender tests, our univariate tests, and our step-down results. So in this case right here, again, the variable we gave priority to, self-efficacy, you can see that there were significant group differences between males and females. And this first test is going to give you the same results or same values and everything as what we had in the univariate F test. The second group comparison between males and females, involves controlling for or covariating out self-efficacy. So you can see right here that your F values that are printed out right here and here are different, as well as the P values that are printed out here and here. So, but even after controlling for self-efficacy, there were still gender differences on perceived utility. Then, for the third analysis, we are looking at differences between males and females on intrinsic motivation, controlling for self-efficacy and perceived utility. And so here's the F value from the univariate test, the F value from the step-down results, where we're controlling for these two variables. And you can see actually we still had statistically significant group differences between males and females on intrinsic motivation. So, in a nutshell, the results that we see in the step-down analysis also pretty much mirrored the univariate results. Oftentimes it's not going to work out this nicely, but yeah, that's just kind of the way it frequently works out. But so the results that you're seeing right here are actually a little bit unusual, but certainly can happen. All right, so let's look at the relationship between the interaction term, which is formed by intervention by gender. So when we look at the step-down test here, when we look at the relationship between the interaction term and self-efficacy, again, these results are going to mirror what's in the first line of the univariate ANOVA results. So there were significant. There was a significant relationship between the interaction term and self-efficacy. When we look at the interaction term as it relates to perceived utility, it actually turned out that that was significant as well, even after controlling for self-efficacy. Here, so you can still see that the F value that was presented here and presented here are different. This one reflecting just a zero-order relationship between the interaction term and perceived utility. For the final step-down test, you see that the interaction term happened to be also significantly related to intrinsic motivation. Once again, there's your F value, which is from a zero-order relationship. This is after controlling for self-efficacy and perceived utility. So again, the results ended up largely mirroring each other between the univariate results and the step-down results. Oftentimes, though, it's the case, again, that when you start controlling for the shared variation among the dependent variables, that you end up starting to see non-significant results at later steps. But that's not what happened here, and at any rate, that pretty well sums up how you can go about looking at following up a MANOVA using step-down analysis, or rather following up a factorial MANOVA using step-down analysis.